Howdy, this video will cover domain and range of linear functions. Alright, but first let's cover sets. What is a set? A set is a collection of things. So for example, the set of things on my table when I wrote this PowerPoint was a tea maker, stylus, computer, iPad, onion, picture frame, Christmas tree, paperwork, and bills. All of these things were on my desk at the time I wrote this PowerPoint, so that is a set of things that were on my desk. Okay, so next example, the set of all real numbers will be from negative infinity to positive infinity. So every single number. Then set number 3, the set of numbers between 1 and 5, including 1 and 5. So 1, 2, 3, 4, and 5 is the set. Domain and range. What is domain? Domain is the set of values consisting of the function's inputs, or in other words, the x values. What is range? Range is the set of values consisting of the function's outputs, or the y values. What is set notation? Set notation is pretty much just a proper form of writing a set, so a proper math form. So pretty much if we were to write this as a set, which is the solution set is x such that x is greater than -1 and less than 5, you would write it just like this. X such that -1 is less than x and x is less than 5. That's it. So some examples. This right here means all real numbers, or shorthand would be like that. So that means all real numbers. All real numbers. Okay, and in solution, well, in set notation, you would write that as open brace x such that now all real numbers is from negative infinity to positive infinity. So you'll have x such that negative infinity is less than x and x is less than positive infinity. Oh, one thing also, this is called a brace, this is called a bracket, and this is parentheses. Don't forget that. Oops, parentheses. Okay, and then another way of writing all real numbers in other math classes, so if you get into higher level math, it will be written as this. You have your brace x such that x is within all real numbers, and this symbol here means within. Okay. Now for this symbol here, x is not equal to 0. In set notation, you write it just like this: open brace x such that. Now, if you have numbers, all numbers except for 0 is what this means. So you would write that as x is less than 0, meaning all numbers between negative infinity and 0, not including 0, and x is greater than 0, meaning all numbers from 0 to positive infinity, not including 0. And that's how you'd write that. This last one's pretty simple. -3 less than x less than 2. Pretty much just put this into your set notation. So your open brace x such that -3 less than x less than 2. Done. Now, interval notation, our second form of notation, is a notation for representing an interval as a pair of numbers. These numbers will be the endpoints of the interval. So from our previous example, we had our set of 1, 2, 3, 4, and 5. The interval notation of this set would be taking the endpoints 1 and 5 and then closing them in the same brackets or parentheses. So since we use brackets, bracket. So the interval notation of that set is 1, 5. Parentheses or brackets are used to show whether the endpoints are included or excluded, respectively. So for our brackets, we use those whenever you have a equals to inequality, and that means they're included. And then parentheses whenever you have a not equals to inequality. No. Oops. And means excluded or not included. And then here's our example. We have our bracket 3, 8 parentheses. which means the set of real numbers between 3 and 8, including 3 and excluding 8, meaning we include 3, but we don't include 8, pretty much, but we do include 7.9999999, just not the actual number of 8. So here's some examples. Let's convert these into set notation, well, into interval notation, and then put them on the number line. So first, our interval notation uses our endpoints of our sets, which for this one, our first one will be -3 and 4. So put -3, comma 4. And since we have an equals to symbol, use a bracket, equals to symbol, bracket. That's it. And then the endpoints of our second one are 1 and 3. They're both less than symbols, so then they're not equals to, so use parentheses. Then our last one, our endpoints are -5 and 2. And we have an equals to, so use a bracket. We have a not equals to, use a parentheses. And that's it. Now we need to put this on the number line. So our number line uses open circles and closed circles. Closed circles are for equals to symbols, and open circles are for not equals to symbols. So now let's go ahead and go to our interval notation, and since it starts at -3, we're going to go to -3. And since it's a equals to symbol inequality, we're going to use a closed circle at -3. And then again at 4, it's a bracket, so use a closed circle. I guess I should also put that too. So closed circles are going to be brackets. And then open circles are going to be parentheses. And then once you have your two lines, you're just going to connect the dots. Now for the second one, we have 1 and 3, so go to 1. And since it's parentheses, we're going to use an open circle. And then at 3, it's parentheses, so open circle. And then just connect the dots. For the last one, we start at -5. It's a bracket, so use the closed circle. And then 2 is a parentheses, so an open circle. And connect the dots. Now our domain and range of our graphs. Domain deals with the x-axis. And range deals with the y-axis. And for domain, for our sets, we want to go from the smallest number to the largest numbers, meaning from negative numbers to positive numbers. So for domain, you're going to go from left to right. And then range will be from bottom, because negative to positive is bottom to top for your range. Now, here are some examples. I don't want to do all of them. I'm just going to go ahead and do this one right here. The domain for this graph is from left to right. So find your leftmost point and go up to your x-axis, which is -4. And then go to your rightmost point, go to your x-axis, that's 3. Now, if you can tell, both of these are closed circles. So we're going to have brackets. Now let's go ahead and convert that to set notation. So we're going to have our open brace, x, such that our first number is -4. And then a bracket means less than or equal to x. Our other bracket is less than or equal to 3. And then our closing brace. Now we need our range. Our range is from from bottom to top. So go to your bottommost point and go left. So -4. Topmost point, go right, 3. And again, they're closed, so closed, brackets. All right, now since we have the same, since our graph is a linear equation that goes to the origin, that means that our domain and range will be the same. So since our domain and range will be the same, go ahead and just copy our set notation to the bottom, because it's the same numbers. But instead of x, we're going to use y because range deals with y. So y such that -4 less than or equal to y less than or equal to 3. Alright, and that's domain and range. Next, let's go ahead and do the right one. So the domain for our right graph is from left to right. So that's going to go down -4. It's going to go to 3. And so then if you can tell, this right here is open. So we're going to have a parentheses. This one here is closed, so a bracket. Now convert that to set notation. So opening brace, x such that our first number, -4. Parenthesis means a less than sign. X. Bracket means less than or equal to 3. That's your set notation. Now range. From bottom to top. Now, whenever we do range, go to your bottommost point. Bottommost part of the line. So not exactly this point here, but the actual line right here. And that bottommost point is at 1. So our range opens at 1. And it closes at 3. Okay. Now, is our 1 going to be included or excluded? It's going to be included because as long as there is not an open circle right there, then it will always be included. So use a bracket. And now, the top, we have a open and a closed. Oh man. Well, pretty much the closed is more important than the open. So we're going to go ahead and say that 3 is included as well because of this included dot. So now convert that to set notation. You're going to have your open brace, y, such that, and then your first number, a bracket means less than or equal to, y, bracket is less than or equal to last number. Okay, and there we go. Last one. Let's go ahead and just do the right one. So domain is from left to right. So the leftmost point is here, -2. And then the rightmost point is this arrow, which is at 4, but doesn't mean it is 4. The arrow means infinity. So since it's going to the right, it's going towards the positives on the x-axis, it's going to be positive infinity. And since it's a closed 2, that'll be a bracket. And we can't ever touch infinity. Therefore, we're going to have a parentheses because it's not included. So convert that to set notation. So opening brace, x such that. Now, how are we going to write this? We can write -2 less than or equal to x less than infinity. Or, since all of our numbers are larger than -2, so the -2 to infinity, we're just going to put x is going to be greater than or equal to -2. And now for range, we're going to go range, and then range is from bottom to top. So we have an arrow at the bottom, meaning our lowest number will be -infinity. And then our topmost number is +2. And since we can't touch infinity, it'll be a parenthesis, and then 2 is closed circle, so it'll be bracket. Set notation, open brace, y such that since our numbers are all the numbers below 2, because -infinity to 2 is all numbers below 2, we're going to have y is less than or equal to +2. Close brace. And that's it. Thanks for watching. Don't forget to do your notes and do your work and all that other crap.